Hello, geometry students. Mrs. Myers here. We are on lesson 4 today, which is actually the last lesson on angle and arc measures. We are going to be talking about two different rules today for finding measures of angles based on intercepted arcs. And as has been stated before, it is based on the position of the vertex. Okay, very, very important. Always realize that. Okay, so the first rule we're going to go through is when the vertex of the angle is inside the circle, but really more specifically not the very center of the circle, because we already did that rule before. Okay, so if we're talking about finding the measure of angle 1 right here, okay, see how the vertex point E is somewhere inside the center of the circle, but not the center. You have this rule: the measure of the angle is equal to half of the sum of the measures of the intercepted arcs. Okay, plural. Okay, 2 of them. So here's how we get the intercepted arcs. Okay, so you take angle 1, right? This angle right here. Let's think about naming it with 3 letters. So angle PER, right? So what we're going to do is we're going to close that angle, and we pass through arc PR. Now, that's only one of 2 intercepted arcs that's needed. So as hopefully you do know, because we've done this many times before, this angle 1 right here has an angle that is vertical to it. That would be this angle right here, and they would share the exact same measures. So what you need to do when finding the measure of angle 1 is really also think about finding the measure of its vertical angle, which is to do the same thing, and that is close the angle and see what the intercepted arc is. So this angle is SEQ, right? So close that angle, and you would pass through arc SQ. Well, those are the 2 arcs that you need to add together and take half of. Okay, so it's basically an average of the intercepted arcs. All right, so let's take a look at this rule being used. So here we got to find angle 1. So of course the vertex of angle 1, I know we don't have names here with letters and everything, but it is still inside the circle. Okay, not the center. The center would be point S here. So what we're going to do to find the measure of angle 1 is we're going to take half of the average of the intercepted arcs. Notice how I'm showing you the rule, okay, the use of the rule. Please do that for me, okay? That's the only way I know that you're finding the measure of the angle the correct way, as opposed to just maybe making a calculation error if you get the wrong answer, all right, is show the use of the rule always, all right? And then we just add these together, which is 92, and then take half of 92, which is 46, all right? Now we come over here and we have to find the measure of angle 5. Now the thing about angle 5, okay, is if we close angle 5, okay, that would be the intercepted arc, and the angle that's vertical to angle 5 here, and we close that intercepted arc, close the angle, and that's the intercepted arc. We don't have either of these, okay? But if you look at the diagram, we do have these 2 arc measures here and here. So what if we were to find, let's just call this angle 6, for example, okay? What if we were to find the measure of angle 6 instead? I could have put the 6 right here. It wouldn't have mattered, obviously, because they'd be vertical angles and they'd be the same measure, okay? Well, this having the vertex somewhere inside the circle, I would follow the same rule that we just did, which is half the sum of 2 intercepted arcs. So close this angle right here. I'm calling it angle 6. You pass through the 90-degree arc, okay? Close its vertical angle, which would be right here. It passes through this intercepted arc of 130 degrees. Okay, so you add those together, which is 220. You take half of that, which is 110, right? Now that is not the end of the problem. Okay, that's the measure of angle 6, right? Well, how do the measures of angles 5 and 6 relate to each other? Well, they're adjacent angles on a straight line, which means they add together to be 180 degrees. So now the measure of angle 5 is 180 degrees minus that 110 measure that you just found. And so now you have your answer of 70 degrees for the measure of angle 5. Okay, so anyway, that is that rule. So we'll come back and do a couple other problems with it later on in the lesson, but let's go through and do our other rule, okay? So now we're going to take a look at the vertex of the angle being outside the circle, okay, as opposed to being inside the circle. It's outside the circle. Now, very, very similar rule. Okay, we've got 3 different examples here, only because there's 3 different ways to get the vertex to be outside the circle. Okay, before there was only one way to make the vertex be inside the circle, and it was with the intersection of 2 chords. That's why we only had the one diagram before there. Here, there's 3 different ways that will make it happen, and I'll talk to you about that in just a moment. But it is equal to, here's the rule, it's equal to half of the positive difference of the measure of the intercepted arcs, okay? So you're going to subtract 2 arcs and you're going to take half. Now when it says half of the positive difference, that just means that you always want to subtract your angles, your arcs, subtract arcs, okay, as bigger minus smaller, okay? You don't want to subtract the arcs in the other way because then you'll get a negative measure. You want to subtract the arcs always bigger minus smaller. All right, so here's how we have 3 different ways that the diagram can be drawn such that you get the vertex of your angle to be outside the circle. Is you're going to have 2 secants, okay, drawn to a common external point. Okay, so this angle P, okay, has the vertex outside the circle. Now, if we were to name that with 3 letters, we can call it, for example, BPE, EPB. Of course, we can even call it APD or PDA, DPA, I mean. But regardless, you know, that angle also could be just called angle P here, and that has a vertex outside the circle. So you're going to need the difference of 2 intercepted arcs. So what you always want to do, though, is you want to follow the sides of that angle all the way out as far as they extend, and then you want to close that angle. Well, there is a larger intercepted arc that you will pass through. That would be arc BE, so notice how that's first. And then there's a smaller intercepted arc that you'll pass through, and that would be arc AD, so notice how that's second, okay? So you just subtract those 2 arcs and take half, and you'd have the measure of your angle. Now, here's another way that the diagram can be drawn, is to have a tangent with a secant, okay? So here's your secant, okay? QHJ is your secant. And here's your tangent, okay? Remember, tangents only intersect the circle in 1 point, okay? So tangent QG. So you'd still get this angle, let's call it, it's being called angle Q here, whose vertex is outside the circle. So you're still going to use the exact same rule. Now, if you extend those sides of that angle all the way, and then you close that angle, you would get this larger intercepted arc right here, angle arc GKJ, so that has to go first. Then you'd pass through this smaller intercepted arc, arc GH, and then notice that would go after the subtraction, okay? Because you always want to do bigger arc minus smaller arc, then take half, and that gives you the measure of the angle whose vertex is outside the circle. All right, last but not least is we've got 2 tangents drawn to a common external point, and that still makes the vertex of the angle outside the circle. And we're going to follow the exact same rule. So we are going to have major arc MTN as the larger intercepted arc, okay, right here. Okay, when you close that angle, that major arc that you'd pass through, okay, right there, MTN, and then you'd have this smaller intercepted arc that you'd pass through, which is arc MN, okay, that's the minor arc. And because you're talking about 2 tangents here being drawn to the circle, so each tangent only has 1 point of intersection with the circle M over here and N over here, those, okay, 2 points actually are the endpoints of the 2 arcs that you need to use. Okay, so there's major arc MTN, and then there's minor arc MN. Now, hopefully what you remember, what we've already talked about, is that these 2 arcs put together make up a full 360 degrees. So typically you would not be given both of those measures. You'd be given one, and that would automatically tell you that the other one is 360 degrees minus the first one. It doesn't matter if it's smaller than bigger or bigger than smaller. And then you'd still follow the same rule, which is to subtract the intercepted arcs, bigger minus smaller, take half, and there you go. There's the measure of your angle whose vertex is outside the circle. All right, so let's see that in action a few times. So very, very straightforward. Find the measure of angle 1, whose vertex is outside the circle. So I've got 2 intercepted arcs clearly given to me here. If I close this angle, I've got 80 degrees and 40 degrees. So all I do is just subtract them and take half. Okay, so subtracting them gives you 40. Half of 40 gives you 20, and then you're all set. All right, little bit different for this example here because I don't know one of the measures of the intercepted arcs, but yet I do know the measure of the angle whose vertex is outside the circle. So you see what I did here when I was looking to solve for the measure of the angles? I just wrote that equal to, and then I wrote the rule. So now I'm just going to go like this. 20 degrees is equal to, see, because this is the measure of the angle whose vertex is outside the circle. That's equal to 1/2 of 70 minus x. Okay, you see that how like I still use the same rule, okay? This is the larger intercepted arc, 70 degrees. Here's the smaller intercepted arc, x number of degrees that I'm trying to find. When I subtract those and take half, that will give me the measure of the angle whose vertex is outside the circle. So here's what I suggest we do, okay? two things, is you can either distribute the 1/2 to clear the parentheses and then just solve the equation. And there's no big problem with that. I mean, half of 70 is 35, and you could just put the 1/2 in front of the x. Or let's get rid of the 1/2, which is to multiply by a 2. Right? And then I'll just have 70 minus x. So then you multiply the other side by a 2, which gives you 40. And now all you got to do is minus the 70, which gives you negative 30 equals negative x. Divide out that negative 1, and there's your x equals 30. And, you know, if you then think about the rule, okay, 70 minus 30 would be 40, and half of 40 would be the 20. So you're all set. All right, let's try a little bit more. So now let's take a look at this diagram, okay, where we've got the two tangents. Remember, we were just talking about that before. See how we've got to find the measure of this angle, okay, whose vertex is outside the circle. So I know I'm going to do 1/2 of the difference of the two intercepted arcs. Well, if I look at these two sides of the tangents, okay, coming all the way together, these points of intersection with the circle here and here show us that there's going to be a major arc between them and a minor arc between them that I have to subtract. So I've got the major arc given to me as 220, but I don't have the minor arc given to me. No big worries, because if I just do 360 minus 220 and get 140, that is the measure of this minor arc right here, because these two arcs come together to make up the full circle. So now I just subtract them, which is 80, and half of 80 is 40, and I'm good to go. All right, one more on this page here. So now this follows very, very similarly from what I just did here and here, two ideas put together in the same diagram. So first, I want to find the value of x, which is the smaller intercepted arc with this angle, okay, whose vertex is outside the circle. So I have to follow my rule of 1/2 of the difference of two intercepted arcs, and that will give me the measure of this angle of 50 degrees. See how I kind of set that up like that before? Now I'm going to do the same thing here. But I don't have this larger intercepted arc, I only have the smaller one, which is the x. But the thing is, I do know what the larger one is with respect to the smaller one, because they come together to make up the full circle. So this larger one is 360 minus x. See what I just did here? I just did 360 minus 220 to give me 140, right? That's what I do here. I just do 360 minus the minor arc, gives me the measure of the major arc. So now I put that before the subtraction, and I don't need parentheses around that because it's before the subtraction. But if I was to put it after the subtraction, then any binomial following the subtraction would need parentheses. So here's what I'm going to do. Okay, I'm going to combine my like terms. Negative x means I've got 360 minus 2x. Okay, and now I've got two choices. Well, I could do what I did up here, which is to multiply both sides by 2. Nothing wrong with that. I already showed you how we could work that out. Or I could distribute the 1/2. Now here I'm going to distribute the 1/2 because look, half of 360 is 180, so that's super easy to do. I don't really need that degree symbol. And then half of 2x is just 1x. So again, it doesn't really matter which you do. It's going to be fine either way. And then I just minus the 180, and that gives me negative 130 equals negative x. Okay, divide out that negative 1, and there is your x equaling 130. And of course, you could always check that, because if you put 130 here, then that would be 230, and 230 minus 130 would be 100, and half of 100 would be 50. So you can always just check your answer. All right, so now let's take a look at a couple problems where we've got more going on than just one simple rule at a time. Okay, these are the ones that get to be a little more challenging for folks, so I figure we'll go through a couple and see how this works out. All right, so anyways, we are looking at an example that gives us a measure of an angle C as 40 degrees, and this vertex is outside the circle. We've got a measure of this angle right here, 28 degrees, for angle FDE as 28 degrees. All right, we're told that this is circle A, okay, so as we've already talked about, that means that A is the center of the circle, okay, so that's important to note. And we want to find the measure of angle FGE, which is right there, and that is a vertex on the circle, so that follows a rule from lesson 3 that was prior to this. No, lesson 2, that's right, lesson 2. And then find the measure of angle FHE, which is right there, and that is a vertex being inside the circle, not the center though. So that's the rule, that we just went through here in this in this lesson. So anyway, here's what I'm going to show you, okay, is that, each one of these, okay, rules, okay, is dependent upon intercepted arcs. And because we've got labels in this diagram with everything, I'm gonna write down what all the measures, all the names of the arcs are, just so we can really follow this. Not that I need you to do it by naming, but you always want to show that you know the rule, okay? So starting with the measure of angle FGE, okay? See, I know that that angle whose vertex is on the circle is simply going to be half of the measure of an intercepted arc. And so when I close angle FGE, okay, when I close that, I'm just going to pass through this intercepted arc right here, arc FE. Okay, so as soon as I get that measure, I'm going to have that measure of that arc, I'm going to have the measure of that angle, but I actually don't have that arc given to me. But I do have this measure right here given to me. And if you think about it, okay, angle FDE has that exact same intercepted arc. So if this rule, because the angle has the vertex on the circle, is to take half the intercepted arc to get the angle, that's exactly what's going to happen here. Okay, the measure of angle FDE, okay, the vertex is on the circle, is going to be half the intercepted arc to get the angle. Well, this right here, so I'm going to write that down. See, the measure of angle FDE is equal to half the measure of arc FE. Oops, I put that in twice. Okay, and since I know that this measure is 28 degrees, okay, and to put a half, then I know that this arc, okay, is what I need to take half of to get 28. Well, multiply that by 2, and now I know that this arc has to be 56 degrees. Okay, so as soon as that is 56 degrees, well, now I know half 56 degrees. Well, it's obviously right back to that same 28 degrees that I had for the measure of angle FDE right over there, because those, two angles would have to be congruent angles because they had the same intercepted arc. And they're both angles whose vertex is on the circle, so they are both going to follow from the same rule. All right, so anyway, let's take a look at the other angle right here, measure of angle FHE. Okay, that's the other angle that we want to find. Now this vertex being somewhere inside the circle means I'm going to take half the sum of two intercepted arcs, okay? So FHE, when I close that angle, okay, I'm going to pass through arc FE. And I actually know now that that is a 56-degree arc, okay, so that's great. But that's not the only arc that I need. So how do I get the other intercepted arc when the vertex of the angle is inside the circle? Okay, is I have to find its vertical angle. Okay, so think about the vertical angle to this, which is angle DHG. And I'm going to close that angle. Well, I'm going to pass through this arc right here, which is arc DG. Now, I don't know what that arc is. Okay, I just don't know it. And really, what I have to do to get that measure, so I got to look at some other information to the problem, okay? Now, it could have been this, okay? It could be that I'm going to use the fact that the measure, this diagram is circle A, which means that DE is a diameter. So I actually could, find the measure of arc DF now because of FE being 56. This is just 180 minus it. But that still doesn't tell me what this arc is right here, okay? But I got to look at some other information, okay? I know that this angle right here, angle C, whose vertex is outside the circle, I know that measures 40 degrees. So what's the rule, okay, when I'm finding the measure of an angle whose vertex is outside the circle, is I got to take half the difference of two intercepted arcs, okay? Well, if we follow the sides of angle C all the way out, okay, that arc, DG, is the larger of the two intercepted arcs that I would need the measure of to get this angle. And if I, again, follow the sides out and close the angle, this arc right here, FE, is the smaller intercepted arc. Okay, so that's just basically putting together all the names of the angles and the intercepted arcs that follow from the rule, with the vertex being outside the circle. But now let's see what I've got. I know this angle is 40 degrees, and I know that this arc is 56 degrees. So how about I just call this an X? Because now I can solve that. Okay, so I just did that before. So I can either distribute the 1/2, which is fine. I can write 1/2 X minus 28. Or if I don't want to have to solve it with a 1/2 in front of the X, I'll just multiply both sides by 2. okay, and write 80 equals x minus 56, and then I just add the 56, and that gives me my arc being 136 degrees. Well, now that I know that that arc is 136 degrees, I can come back over here and I can finish up this problem. Okay, so I just have to add 136 and 56, which is going to be 192, and then take half of 192, which is going to be 86. No, 96. Yeah, 96. Okay, and then we're all set. Okay, so one more. Ready? Let's find the measures of angles A and B. Now, both of these angles have their vertex on the circle. Okay, so each of those is simply going to be half of an intercepted arc. Okay, half of an intercepted arc. Okay, but which intercepted arcs in what measures? Okay, so angle A. Okay, if we think about three letters that name that angle, it'd be E, C, I think this is a B, okay? So that would be arc EB, which I don't know the measure of it, okay? Then I've got the measure of angle D, oh, sorry, lowercase b. Why did I write it like that, okay? And that right here, okay, is going to, think about follow the sides of that angle all the way together. If I named it with three letters, it'd be angle CBE, okay? That would pass through arc CE. Okay, so I got to find those two arcs. Now let's see how I can get them. Well, first, I know that this angle of 87 degrees has been given to me, so that's got to be helpful. And I got this measure, 74 degrees, that's been given to me. That's got to be helpful. All right, so let's look at the 87 degree measure first. I'm going to do that one first because the vertex is on the circle. So that just means that that measure, okay, of angle CEB, okay, that's that 87 degree measure, okay, is simply going to be 1/2 of an intercepted arc, and that arc would be CB. Okay, now don't assume that that is a diameter. There is nothing in this diagram that tells you that this is passing through the center of the circle. So you have to be told that you've got the center of the circle. That's how you'd have a diameter, okay? So that's not the case here. So I'm just going to look at this angle, okay, 87 degrees. And for example, I can call this an X, okay? And what measure would arc CB have to be so that when I take half of it, I get the 87 degree measure? Well, then obviously just multiply both sides by 2, and you get 174 degrees as this arc. Okay, so that's good for that arc, but I still don't know these other two arcs that I need in order to get the measures of angles A and B. So I'm going to keep going to the other information. So I have this 74 degree angle, okay? Well, that angle, I could just call that angle D, okay? That's 74 degrees. Because that vertex is outside the circle, I'm going to find half the difference of two intercepted arcs, okay? That's that rule that we just did here before, okay? So I'm going to follow the sides of that angle all the way out. And when I do, think about three letters that would name this angle. The angle D would be CDB, for example. The larger intercepted arc that you would pass through is CB. Well, I just found that that's 174 degrees. So that's great. And then the smaller, see, follow the sides of the angle out and then close the angle. The smaller intercepted arc would be arc BE. And that one I don't know. So how about I just call this a Y? Okay, and now I can solve for it. So I'm going to multiply both sides by 2. Okay, and that is going to be 148 over here is equal to 174 minus y. Okay, so I'm going to minus the 174 degrees from both sides. Okay, and that gives me negative y is equal to negative 20. Wait a minute. 6. Yeah, negative 26. And then that would tell me that this would be just positive 26. This is 4 just divide out the negative 1. All right, so now, okay, that I know that arc, okay, well, that arc is what I just needed to take half of to get to the measure of angle A. okay, which is just half of that 26, and now that is 13. Okay, and finally, I can get the measure of angle B, because in order to get this arc right here, I just have to remember that these three arcs come together to make up the full circle. So if I just call that a Z, okay, now I could just know that 174 plus the 26 plus the Z would equal 360 degrees, okay? So this adds together to be exactly 200. So that must mean that this arc is exactly 160. And now I just take half of 160, and that would give me 80 degrees for the measure of angle B. All right, so I hope that has helped you to understand these two rules. And again, these are the last and final two rules. All right, hope everyone is doing well and that you're excited that this is our last week of online learning. All right, goodbye all.